Really appreciate that I have this opportunity to talk to the community. I'm from Pinterest. I joined about 3 years ago. We've been using Finagle about over 2.5 years now, and it's handling millions of QPS for us. So I'm just going to really quickly go through what Pinterest is. Pinterest is really solving a discovery problem. What does it mean is that if you know exactly what you're looking for, you go to Google, you type it in, and Google typically give you something you exactly are looking for. But for questions like what I'm gonna have for my dinner, or what kind of art pieces I may like, and that kind of question, you go to Google. Google may not give you a satisfactory answer. And we build a service that try to help you discover things you like. We do that by, you can get onto our service and follow users and boards, and you get a home feed. It's kind of similar to what you get from Facebook. You sort of friends people, or you get to Twitter, you follow people. But we also recommend stuff to you based on the stuff you've interacted in the past. And we also make interests really a first-class citizen. The interests are really clusters, and then they're related to each other, and we expose to you the related interests, and then you can navigate through this and really find stuff you like. And any problems, when you solve those problems at scale, it becomes much harder. And we got 50 billion pins, and we got 1 billion boards, and people put all those pins into boards. And they actually categorize all the stuff for us, and we get much cleaner data. And that's sort of, with good data, it comes really good. Your machine learning and all that stuff works a whole lot better. And we're roughly doubling our data set, every 6 months. Now I just want to talk a little bit about, the service-oriented architecture transition we're going through, and why we pick, Finagle as a framework to do such a transition. So when we get started, sorry. Too fast. OK. So when we get started, really, back in 2010, we got 3 founders and 1 developer, 1 engineer. And fast forward to December last year. This is last time we have all hands kind of photo. And nowadays we have about more than 600 employees and 200-300 engineers. And if you're on a monolithic kind of code base, you can imagine that people are going to step onto each other's toe a lot. And then service-oriented architecture, by breaking up this monolithic code base into smarter services, and really a lot of good things happen. One is really the ownership, and also long-term ownership. The service owners, they own a service from its inception, and maintain it, and really knows the context, and working really hard to optimize it and reduce operation overhead because they own it. And another thing is that it really the services talk to each other, and based on some API, some contract, as long as the contract stays the same, within you have sort of the flexibility to change anything. But if you're not meeting your SLA, and people are they also know who to talk to. So there's a lot of really good things happening with service-oriented architecture. Also, but of course, there's a lot of more complexity comes with service-oriented architecture, because Marius went through that in a lot of details. But what really that means is that if you're going to service-oriented architecture with hundreds, 10, 20, 30 services in your stack, you really need a really good service framework and the capability to distribute debugging and tracing, and really knows what happens across your stack. So why Finagle? And then everybody probably all read React Manifesto. And I'm just going to keep this short because I only have 20 minutes. But my promise to you is that if you use Finagle and if you use it in the right way, you get all this in your service. And then the other thing is like, when we get started, we're really just a Python shop and it's a Django app. As the service gain popularity, we have a hard time in scanning to meet the load from our users, and because the way how we use Python as sort of a single process, a single thread way. And then if you can imagine that, let's say you have 100 server, and there's 100 requests coming in, and every server now pick up one request and deal with it. And if your backend somehow, your database is slow, and that's it. You can only handle 100 KPS. But what it really needs is that you need the capability to handle all those concurrently. But that means that you need to do the logging and all that, stuff correctly. And for a code base that was not built with that in mind, it's actually really hard to do. But lately, we introduced something called G-Event into our stack, sort of partially solve the problem, but just to be honest, like Python compared with the JVM-based language like Java or Scala, it's much slower. And we really liked the future programming model. It's really is so much better compared with callbacks or like Java's native way of dealing with future. Also, Finagle comes with visibility into like what's going on in your server, and it has awesome community. And like if you post questions to the user group, typically I've never waited longer than 24 hours to get somebody to respond to me. So as I said, we come from a monolithic sort of really big code base. We break them up into services. And along the way, sort of, this is a typical sort of best practice we follow, so that we did all that stuff without really introduce huge availability events. And the availability events we had really is like either your dynamic service discovery has issues, or your DNS or that sort of things typically cause huge outages. And with Finagle itself, is always has been robust, and typically it's us who did something wrong, not the other way around. First thing is that when you do this type of migration, you want to avoid change of functionalities. The reason why is because typically you wanted to sort of be able to do some sort of comparison to making sure. Otherwise, if you change the functionality, what do you compare it to? It would make things much harder. And you want to use test-driven development if you have sort of really complicated logic, because if let's say you go do a month-long kind of development, and then you're like, okay, let's try with road traffic. And so that's sort of very not so responsible, and also at the same time, if things are not going as you expected, you're like, where's the problem? So typically, what we do is that we play with dark traffic, and dark traffic, which means that you sort of replay at the same time as the real traffic coming in. It goes into your old system, and you have a percentage of the traffic goes to your new system. And then, of course, there's a complication comes with how do you handle write traffic, right? And sometimes you have some separated data store somewhere else, and then you compare the two. And one way we've been dealing with this is that we replay the traffic based on the user instead of just random if it involves writes, and so that then you can pick that the data belongs to that user to do the comparison. Another thing you need to pay attention to is that when you do this sort of dark traffic kind of mode, and you're really causing additional loading to your system, because you're not only handling your live traffic, you're handling your new system is doing some dark reads or whatever, and that's additional load to your system. You're making sure you have that kind of capacity in place. Another thing is that it really helped us is that our capability of being able to sort of dial up and down the amount of traffic we place through the new system, so that if we find something wrong, whatever, we can dial up and down. And the same thing applies to when you really, everything is ready, you're ready to like, really have your new system handling live traffic. It's the same thing. If you all of a sudden find something's wrong, it'll be nice that you can like real-time dynamically like switch the traffic back to your old system. And just sort of show like, I mean, at this point, it's impossible for me to actually put every single services in our stack into one graph. I sort of just picked, if you get onto our service and create a pin, this is, sort of all the services that's involved to do that. I was planning to cover some of the interesting services we have, but like I only have 20 minutes, so I'll skip that part. We have some people which they're gonna hang around here, and if you are curious about some of the stuff, interesting services we have, and you can ask them. And also I encourage you to go to our engineering blog, and there's a lot of interesting stuff there. So a service proxy. So we have a proxy, and we plug into all of our Java Finagle server. As I said, Finagle give you a lot of visibility already out of the box, like into what the service is doing. But in sort of a distributed system, you want to know, like, let's say you all of a sudden have a load issue. Your service is handling much more than it's capable of. Like, what do you do? And because your service, there could be like 20 different clients, other client cluster calling this particular service cluster. And one thing is really useful is that you want to find out who's the bad apple, who's causing load to your system. And then you need to differentiate the traffic based on the client. Or like sometimes like a particular API endpoint is heated up because somebody has a bug, and you want to figure out which API endpoint is causing the problem. For this type of stuff, out of the box, you don't have that kind of visibility. What I heard in the morning is that it seems like Twitter is building this thing into Scrooge, and once that materialized, and maybe the world is going to be a whole lot better for everybody using Finagle. But if you wanted to do the same thing as we did, it's actually not that difficult. So we use something, we basically use Java dynamic proxy, and it's a way to do code injection. If you have an interface and implementation, then like it's easy to use dynamic proxy to inject some dependency. And then basically we hooked into additional logic to do request logging, to keep track of like a particular request from which client it's coming from, and we record latency metrics based on sort of per client, per API endpoint, kind of and I'm going to show you a little bit like what our request log is like. So you notice the first field is kind of like, from which client cluster the request is coming from. The second thing is like from which client server it's coming from. And also it records like which API endpoint is calling with what parameter. And in this particular case, it's a failed request, what kind of exception you're getting. And then you can we actually hook this up into a real-time sort of a data pipeline. We aggregate along multiple different dimensions. For example, from which client the request is coming from which server the exception is being thrown. Because sometimes you have like 100 servers in your server cluster, and then one of the guy let's say has something bad going on. Some other process is running wild, or whatever happens with it, it just throws way more exception than the others, and then you can easily figure that out. And maybe there's an API endpoint that's bad, and everything else is fine. And like sometimes the exception type will tell you information about like what's going on in your system. So you have this information at your proposal at real time. And then it comes really handy if you have production issues. So the metrics. So this is the what I was talking about is we record metrics at per client, per API, endpoint level. So the first line you can see that it's basically QPS or request count tracking from a particular client. The second line metrics is really for a particular API endpoint from from a particular client cluster. And then the third one is really per API endpoint the distribution of the latency. So you have more detailed sort of information about it. And then I'm just going to very quickly go through like a rel limiting stuff as well. Basically, you want to protect your service. Let's say your client overloading you, and you need a way to shut off traffic. And then this is also built into our proxy because at this level, as I said, we have visibility into which client is sending us the request. And as long as you define some kind of policy with rel limiting, then you can just reject the requests coming from the client. We have basically a real-time way to dynamically change the rel limiting. Dynamic service discovery. One of the key things is that you want the capability to be able to quickly increase the size of a cluster or decrease the cluster if there's not much load going on. And then, unfortunately, this is also one part of the system that could cause you huge pain. And the way how we did it initially was not that different from a lot of other people, which is that you have your server up, and then the server created some kind of ephemeral node in Zookeeper, and that sort of becomes your group membership, and then you're a client basically subscribe to it and knows who's alive, who's dead, and all that good thing, and then you can dynamically manage your cluster that way. But the thing is that we have this happen multiple times in our stack, which is that your Zookeeper now becomes this is a tier 0 component. It has to be always up, has always healthy, and sometimes they're actually on fire. When it's on fire, and then okay, so all the battery has off. So what we did is actually we basically have the group membership. A cluster information stored in a local file, and we have a way to say, if there's a massive difference from the group membership we'll get from Zookeeper, then just reject it. And so this way, we keep a local copy on the disk. So and that typically, and after we put this system in place, we haven't have any big issues with it. As I said, getting visibility into your entire stack is very, very important in service-oriented architecture. And then, but it's very typical for all the organization to have, multiple different languages, multiple different kind of platforms in place. It's not typical to say, we use Finagle, it's Finagle everywhere. Everybody has to write Java, right? So here I just give sort of example. We basically just make every single platform, that's our goal eventually. Right now we only have it for Python. Make it understand Finagle Swift protocol. So the way how Finagle was being able to do this, or the tracing and all that good stuff, is really coming from the power of having a header. HTTP has a header, but Swift doesn't have a header out of the box. And so basically, Twitter guys built this into the protocol. The way how it works is through a handshake, basically sending a magical request from the client to the server. And in this, this name is subject to change, but I just illustrated here. And if the server understands Finagle protocol, it'll respond with upgraded reply, and from that point on, client will just send the header along with the payload, and then when it's getting the response back, it's getting a response header as well. And if it doesn't understand it in Python, it would translate it to a T application exception, and then the client basically knows, oh, the server doesn't understand Finagle protocol, and then just from that point on, just a plain vanilla. So you can basically build the same thing if you have other sort of language platform or framework you're using. And because making, throughout the whole stack and speaking the same protocol, using same kind of convention, is very important because without that, you kind of can't really do much. So I have something else, but I'm running out of time. But basically, if you have a tool to allow people to generate some stable code for services, and it'll boost developer productivity a lot. That's pretty much my talk, and now open up for questions.
Yes, we've got time for a question or two.
Yeah, I apologize that I prepared a much longer version of the talk, and I didn't realize the 20 minutes, so I just rushed through a whole lot of things. But if you're interested in knowing more details, feel free to shoot me email or write me a message on Twitter or whatever.
Hey, sorry. I have a question about service discovery. Why don't you use Zookeeper's observer node instead of actually copying it into a local file?
Oh, so the problem is that that's exactly what we did initially, but that basically requires you to have Zookeeper up and running and healthy all the time. And if Zookeeper is in trouble, then the whole entire stack is in trouble. And that's exactly what we ran into 2 years ago. Labor Day weekend, I was drive to LA. My manager was calling me, and it was a 7-hour outage.
One more question. If you were going to do it all over again, what would you do differently?
Yeah, if I'm doing so actually lately I've been giving a lot of thinking along this. Is I think it should be in general a general pattern is really use Zookeeper as a coordination system and have another system sort of play in the middle. And this applies to service discovery. It also applies to if you, let's say you build a shard manager kind of system, and that's kind of the same way to do this. So have those guys have up to real-time up-to-date information, and have those guys relay the information to the others. And the one I would say, I just gonna very quickly add a detail there. The first time we run into this kind of problem, we add a whole bunch of observers into our system. So the thinking is that the observer can help scale out the reads. But the problem with Zookeeper is that without a certain patch, when any client connecting to observer even, they need to establish a session. Establish a session requires the master nodes, the coordination, and it didn't work basically.